Good morning. Today we are going to see Fourier sine offering sine series under the interval 0 to pi. Already we have seen the Fourier series expansion in the interval 0 to 2 pi, as well as we have seen the formula for the Fourier series expansion under the interval 0 to 2l. Now the offering sine series is nothing but it is a part of the full range series 0 to 2 pi. We can take the interval as 0 to pi. So see the first problem. Determine the off-range sine series for the function f of x is equal to x into pi minus x in the interval 0 to pi. Also deduce that 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube plus etc. This is the first part of the question to find the off-range sine series for the function f of x equal to x into pi minus x. This is the second part. First, we need to find the off-range sine series for the function x into pi minus x. We know very well the off-range sine series for the function f of x is equal to summation n equal to 1 to infinity bn sin nx. In the case of sine series, we are considering a0 and an are obviously 0. So here the Fourier coefficient Bn we are going to find. The formula for finding Bn is 2 by pi integral 0 to pi f of x sin nx dx. Here f of x is given in the problem that x into pi minus x sin nx dx. That is, we have integral 0 to pi x into pi minus x sin nx dx. We can take u as pi x minus x square and v as sin nx. Already I told you all the u's are differentiation and all the v's can be going to be taken as a integrated value. Okay. So our first differentiation u dash can be given by differentiation of pi x is pi into 1. Differentiation of x is 1 minus 2x and then u double dash second derivative with respect to x is differentiation of pi is constant of a differentiation 0 minus 2 and then u triple dash is obviously 0. The third one is the third differentiation with respect to x is 0. Next we can take the first integration of sin nx. Integration of sin nx we know very well. The integration of sin is minus cos nx by coefficient of x is n. The second integration is b2 is integration of cos nx is plus sin nx. Already we have one minus divided by n square. And b3 value is integration of sin nx is minus cos nx. Already we have one minus here. Minus of minus plus cos nx by n2. Now we are going to apply the Bernoulli expansion. The Bernoulli expansion states that integral u dv equal to u v1 minus u dash v2 plus u double dash v3 minus etc. So we can apply the Bernoulli expansion here. U into v1. Already we found that u value is pi x minus x square into v1 minus of u dash into v u v1 minus u dash v2 value is minus sin nx by n square plus u double dash into v3 minus 2 into cos nx by n cube. We can apply all the values in the integrable solution. Then we are getting minus of pi x minus x square. Here we have one minus. We can bring this minus here. Minus of pi x minus x square cos nx by n. Here minus into minus we get plus. Plus pi minus 2x into sin nx by n square. Here minus 2 cos nx by n cube. The limit from 0 to pi. All the offering series limit can be taken as whether 0 to pi. If it is a L form, we can take 0 to L. Now if you are applying the upper limit pi for x, then here we are getting, consider the first term, pi into pi minus pi square. So we are getting 0 here, 0 into anything 0. And the next term is, here we don't get a 0 value, but sine of pi value is 0. Second term is also 0. For the third term, cos n pi value is minus 1 whole power n. We know that already. We know that cos n pi value is minus 1 whole power n. Multiple of all pi's of sine is always 0. So here minus 1 whole power n, and if you apply the lower limit here, 0 into the bracket term 0, and then sine of 0 is 0. The third one is cos 0 is 1 minus of 2 by n cube. So finally out of 6 terms, after applying the limit, out of 6 terms we are getting only 2 terms here. Minus 2 into minus 1 whole power n by n cube, minus of minus plus 2 by n cube. Taking 2 by n cube outside in both the terms, then 2 by n cube into 2 by pi into 1 minus of minus 1 whole power n. So here we are going to check the odd even condition. If n is odd, that is if you are putting n equal to 1, n equal to 1, the least odd number, then we get minus of minus plus, so we get 2 here, 2 into 4, 8 by n cube pi if n is odd, and equal to 0. If you are putting n equal to 2, we are getting 0 in the inside the bracket. So equal to 0 if n is even. So finally we occur the f of x function summation n equal to odd to infinity, because we are getting value only for the odd number. So 8 by n cube by sin nx. Next we need to make a deduction. For that we can write the entire function pi x, f of x can be write it here as pi x minus x square equal to 8 by pi. We can expand the summation putting n equal to 1, n equal to 3, etc. Because here the odd summation series we can putting odd values only for the sign. So f of x at the point x equal to pi by 2. We can take the point of discontinuity as x equal to pi by 2. Then we can bring all the x can be as pi. Then pi into pi by 2 minus pi square by 2 equal to 8 by pi into sin pi by 2, sin 3 pi by 2 plus etc. So here we have pi square by 4 equal to 8 by pi into sin pi by 2 value 1, sin 3 pi by 2 value is minus 1, etc. On that way we can write. So 1 by 1 cube minus 1 by 3 cube, alternatively positive negative infinite series. We can bring this 8 by pi into the left hand side. We get pi cube divided by 8 into 4, 32 equal to 1 by 1 cube minus 1 by 3 cube plus etc. This is our required deduction. Thank you.